Hey everyone! So in this video tutorial, I'm going to show you how to create the same decentralized application that we created in the last couple of videos in Python instead of JavaScript. So the application is based on this smart contract that you probably saw in the last couple of videos. And if you haven't, it is here on my GitHub. So just make sure to click on the link below the video to access the smart contract and the decentralized application. So this is the smart contract, very basic, just a donation contract that I built so other people who appreciate my services and the free content that I provide could donate to my digital wallet, right? They're donating ETH in this case. And so this contract, or at least decentralized application, has two main parts. This part where they can donate, tell me the reason, and then donate the money. Let's put this as an example. Donating for your video on Ethereum or on Polygon, because this is a Polygon network. And I'm going to donate 58 Wei. So very little money. Oh, forgot to connect to our MetaMask wallet. Okay, connected, 58. Now let's make it 67 Wei. Submit. We're going to ask the user to confirm the donation, and this transaction will transfer the 67 Wei from the user's wallet. In this case, I have as a test ETH to the contract owner, which happens to be me as well. And we can see that this worked because if we click on see donations over 45 Wei, now we'll see that we have this three main donations. Oh, I think we have to. It takes some time for the blockchain to validate this block, so might want to refresh. And what we have to do is actually, I forgot, is actually look at the record, right? If we refresh this Polygon Etherscan, where we can see our smart contract, right, and all the details, we see that a minute ago this transaction took place, right? And this transaction is on this block. This is the latest block. So I'm going to go back to my code and I'm going to put this latest block. I should probably just put the word latest. This should also work. It's going to refresh, and now this should work where we'll see, 67 Wei donating for your video class. And so all of this is done in Python based on this smart contract. So let us get started and let me explain the code to you so you can build your front end in Python. If you have questions along the way, definitely ask them in the comment section of the YouTube channel. If you want to support this free content that I provide, you cannot use this smart contract yet because I didn't deploy it on the main net. This is just a test net. But you can join my Patreon or you can become a member on this YouTube channel. All right. So to download the code, I prepared this decentralized app for you. It's all in this GitHub link I'll put under the video. And we're going to look into, you're going to need all of this, especially the static folder and this signer JavaScript you'll need. And then you'll need this donation front end. We're going to go over this together today. So pause the video, download this into your computer like PyCharm or VS Code, and open everything up, and let's look over this together. All right, so let's go here. Let's open the file, donation front end. Make sure that your folder looks like this. You have a main folder wherever you want to put this, desktop, or I called it donation to educator dash. Static folder, inside of it you have the signer info.js, and outside in the root you have donation front end. This is how it should work. Now you have to install a few libraries if you don't have them. I am going to add a requirement.txt file here so you know what libraries you have to install exactly, but it's really right here. Dash and Dash Bootstrap, you have to install these libraries. All right, once you install these libraries, you import everything you need from them. And we're going to add this theme, this Bootstrap theme that makes the app look like this, you know, black in the background with these buttons, colors, this font. And then we're incorporating this script, the signer info JavaScript, which we have here under the static folder. This one is going to be used to connect to the user's MetaMask wallet. So we have to incorporate it into our Dash app by assigning it to the external scripts. And then we have our layout. And in our layout, you'll see this is a big part of the code, 22 to 115 line of code. But it's really just explaining what's on displayed on the page, right? So we have the first one, we have an H1 and header, like here. And then we have this small alert that is invisible because is open equals false. But whenever we click on this button, is open will change to true. We'll see that soon down below. And then we have an empty row for about 20 lines of code. And here you have the label, a reason for donation, an empty input field. You see the value is an empty string. There's nothing in there. It's going to be text. Whatever we type in there is going to be a text type, not integer or dictionary. Is going to be text. And then just an ID that we will use later to connect all the components together. Same thing below, another row, another label right here, another input field, pretty much just copy paste with a different ID. And below we have the button. Now you can just do this button. You don't need all of this div, but I put this button inside this div because I'm using Dash Mantine components, a cool library built on top of Dash. I'm using that for the spinner, right? This is going to be the loading overlay. So when I click on submit, you'll see I just have to connect to my MetaMask. There we go. But once I click on submit, you'll see this spinner happening, right? I'm going to reject this action. But this spinner is because the button is inside the loading overlay component of Dash Mantine. All right. And then below we have, oh, I skipped a little bit. This is the button here. And then we have go through history of donations. And then we have another button inside another overlay with loading effect number 2. So a slightly different ID. And then underneath we have an empty div. Children is empty. There's nothing underneath here, underneath the button. But here is where we will put the table. All right. So now let's look at this button first, and the callback that allows us to click on the button and then create this AG grid table. All right, so let's see how we do it. We'll go all the way. We'll skip the first callback, the 117, and we'll go to the callback below, starting on line 138. So in Dash, you have a callback decorator, and you have a callback function. The callback decorator will have an input, and in this case, it will be the component property will be enclicks of this get data. This is the ID. So what is this ID? Get data, get data. This is our second button, this right here, right? This button right here, the purple one. So we're going to take the enclicks, which is 0, and we're going to define the enclicks right here, just an underscore. This is going to be the enclicks. So whenever, because this is the input, whenever the button is clicked, the function will be triggered. This will be enclick 1, and then this will be 2, and then this will be equal 3. So anytime this is clicked, the button is triggered, the callback is triggered, and everything is calculated here, and then we return 2 things. And why do we return 2 things, 2 objects? Because we have 2 outputs. First object is returned here to this children, and the second object is returned to this children. So what's the first object? The first object is no update. And this is just a way for Dash to say, just don't update that component of the callback. So we're not going to update the children of this loading effect too, right? This is the loading effect. This is a spinner. We don't need to update it. As soon as we click on the button, this spinner is executed, and as soon as the callback is done, this spinner disappears. So there's no need to update the spinner, because the button is in the layout, is inside the spinner. You see this button is the children of the spinner. Then the spinner will activate above the button. All right. So first object, the spinner, no update, and then the grid is what we build here. The -ag grid, it's a table. This one right here on the right is returned to the children of table space. Now table space, what is that ID? This is this ID. This is a div. So the table is going to be returned right here. Instead of an empty string, we're going to return a -ag grid table. All right, so how do we do that? We activate the function. We click on the button. The function activates. We're connecting to a public RPC, which is kind of like a connection to a node. We use the node connection to connect to Web3. And then this spits out true that the Web3 is connected. You'll see that there's just so much information here, but it's somewhere in here. And then we'll create two empty lists, because we're going to use one list for the amount of donation and the second list for the reason donating, right? So first we build an event signature variable, and this is log data, because if you go to the smart contract, which you can find again under the video, you'll see that the event is called log data. So you have to spell it exactly the same, log data, and this has 4 different variables: a uint, a string, an address, and a uint. So this is what we put in here. And then we'll create the logs variable, web3.eth.getLogs, and we need to establish some information. So web3 knows what blocks it's looking at. This is the address of the contract. I'll add this also link under the video. You have the address of the contract. And then you have from block. We're going to use from the very first time when we created the contract, we're going to insert this block 1,404,600 all the way to this last block 184.0703. I think you can also look it up, but I think you can do something like latest. It should work as well. Let's double check. Yeah, latest also works. So you don't have to update the block with every single number. Just put latest, and it'll give you the latest block. And I think you can put earliest instead of 144. That should work as well. But anyway, you have this, and then we're gonna put this. I never know how to pronounce this, but you need to access the topics. Topics is where indexed variables of an event are saved. If you do not have an indexed variable, then I don't think you need to use topics. But in this case, we have an index variable, so we're going to use topics, and we're going to put the event signature inside of that. Okay, so now we're going to loop over all these logs, right? These blocks, and that have this address, and then we're going to print out every log just so we can take a look at what it looks like. All right, we're just printing out every log right here. And then we'll create a new dictionary that will be kind of like our decoding mechanism. Because everything here, the amount and the reason is either encoded or with hexed variables. So it's really hard to tell what they are. For example, let's look at the amount, right? We said the amount is indexed. So the amount will typically be within topics. If you click on this last transaction and go into the logs right here, you'll see topics. So here's where you'll see this topic number 1 is actually the amount, because remember, anything that we indexed in event log data goes into the topic section of the logs, right? So to access it, I don't understand what this number means, right? This amount doesn't mean anything. It's encoded, so we have to decode it like this: int.from bytes log, and then we're going to topics number 1, which you can see here, topics 1, and you can also see here because we printed out the logs, right? Topics, and it will be not the first one. Let's make this bigger. Topics, and it won't be the first one, but it will be the second one right here, the hex bytes. Okay, topics 1, and then byte order big, and this will allow us to translate the amounts. And when we do event data amount, it will give us the actual amount that we can read, right? An actual integer. Event data reason. Now the reason does not exist in the topics because the reason is not an indexed amount. It's just one of these. It's just a string. And it's just another variable in the event, so it will go inside the data space, right? Again, let's go back so you can take a look. You're going to the last transaction, like that, and then you go into logs, and you see under data, you see many different variables, like 5 different variables. In this case, the reason, I think, I don't know why, but the reason in this case is the last variable. So we'll go into text, and you'll see. No, it's one before last. I wonder what this is. Donating for your video on Polygon. Oh, it's just continuing. Donating for your video on Polygon. So this is the last part of the data, and so we go here, and that's why we do W3 to text because it's in hex. And then we do log data. We'll just take the last 64 because we don't need all of these data. We just need the last 64 bytes or digits, whatever. And this will allow us to turn that to text. If you do -63 or -65, it won't work. It has to be the last 64 because in this case, the reason is the last data set. It was hard for me to understand why the reason here is the second data variable, but in this data set it's the last. But somebody answered me on Stack Overflow with an explanation of how the data variables are ordered. So I'll add that link under the video so you can read more about it and understand for your variables. I'm just printing them out so we can see these things, and then I'll create a filter if the event amount right here, where accessing this dictionary is above 45, then we're going to add this to the list. Remember these two lists empty lists that we created? Add these to the list, amount list and reason list. We're going to put this list inside a pandas data frame with these column names. And then we just could put this panda data frame inside a -ag grid table so it looks nice, like that. df. A lot of this code you can just copy paste. You don't have to do anything different. And then we return this grid. Remember, there's a second object returned to the children of this empty div on top, right here. Okay, so let's try it out again. Let's see, let's type a different reason. Reload, gets the password. Reason for, let's do for ETH tutorial. And the amount, let's do 99. Submit. It will ask the user to confirm the transaction on their wallet. And then, oh no, this is something. Well, here we're creating a new transaction. But once I want to show you that it works because we changed this to latest, right? So now this block number should be included in the filtering system. 99 way successful. Go back to our contract to Polygon Etherscan. Let's go back. We can refresh and see that this was just created in block number 106. It doesn't matter. We're going to put the latest block here, right? And then now let's try and pull it. See donations, and now we see 99. Let's make this bigger. Doesn't look good when it's so small. Bigger, bigger, bigger. Now let's refresh. See donation. 99 for ETH tutorial. Perfect. So we have this symbol here. Got to figure out how to get rid of it, but we got the full string that we wanted from this latest transaction. So now that you know how it works, let's look into this function. How is this function working? This is our second callback. It's the client-side callback from line 117 to 136. In this case, client-side callback in Dash is written slightly differently because it allows you to write code directly on the browser, right? JavaScript code. And we need, in this case, we need a little bit of JavaScript because we are actually connecting to the user's MetaMask wallet on the browser. And the only way to connect to MetaMask wallet is you can't do it through Python. You have to do it through JavaScript because it's on the browser. So we're going to say first, trigger, same thing, input. Trigger this callback whenever this button is clicked. It's a different button. Submit button. Trigger the callback. Here I'm going to do reject. And once this button is triggered, the spinner is activated because we also have this button inside loading overlay inside a spinner. And then we're going to take two state variables. State variables are inputs that do not trigger a callback. So I can change, these are the two inputs, but they're not going to trigger a callback. They're not going to do anything. Only the button will trigger the callback. So I'm going to take these two values. One is this first input field is right here. My class, his class. And the second one is the value of the donation, right? Let's put 3-way. And then it's going to execute this function that we wrote, right? With these three variables. N is the n clicks, value of the reason and value of the amount is of the state. We're going to try these two functions, the checkNetwork and the sendTransaction. Now you might be asking, where the heck are these checkNetwork and sendTransaction functions coming from? This come from the JavaScript file, right? Inside your static folder. So let's look at what these two functions do. First, we're looking at the checkNetwork, right? This function, if it doesn't work, we're going to print console log, right? But let's see what it does. Let's refresh. All right, open this file. First, we're importing the module ethers from this script. This is our contract address. We need our contract ABI, which you can get from the Remix. Once you deploy, you're able to get the ABI in the. Actually, once you save it, you should be able to get the API right here. ABI. This is the ABI. You copy it, and you can put it inside of here. And then our target chain, this is what we're going to check for in the network. This is the target chain for Polygon zkEVM testnet. This is the testnet where we deployed our smart contract. So we want to make sure that the user, that their wallet is connected to the testnet and not something else using this checkNetwork function. Now I know you might be thinking, okay, this is a Python video. Why am I seeing so much JavaScript? Two things. One, you need a little bit of JavaScript to connect to a MetaMask or Coinbase or a digital wallet on the browser because it's on the browser, and Python is not a front-end language. It's in the server back end. But the second thing is you don't have to really change anything. Once you understand what this function does, or even if you don't understand, you can just repeat this function and most of this function for future Python decentralized application apps that you create. Very, very little here has to change. So bear with me. checkNetwork, we're just checking, we're connecting to what the Ethereum on the window, which is the MetaMask provides information on the window browser, and we're checking the current chain ID. And we're saying if the chain ID is equal to this ID that we want, then return true in the console, everything is good. If not, like else, then request wallet switch Ethereum chain. This is the method. So it's going to request the user to switch the wallet. So let's do this, refresh. Let's submit something, doesn't really matter. And we are going to change our, actually let me reject here. Let me change this before. Let me make sure I'm not on, let's be on the Ethereum mainnet, right? I have 0 ETH. I'm going to submit, and now it's going to automatically activate this checkNetwork function. It's going to say allow this site to switch network because it activated this function, the method on line 89. So it says from mainnet switch to Polygon testnet. Yes, switch baby. Then we change this, go back, and now we can submit my whatever. Submit and spinner, and now it's going to ask us to confirm. And it asks us to confirm because once it's done with this checkNetwork function, it's going to go into this next function, which is sendTransaction, right? And this function is right here, await sendTransaction, right? We have these two inputs that we pass into it, and the sendTransaction is this function right here, which after we connect it to the user's wallet right here, get their signer information instead of private key and everything that you cannot see, you don't have access to because it's some random person's wallet. It's all inside the signer variable. We instantiate a new contract based on the signer information. And here's the transaction. We are actually calling the offer donation function. So this, like I told you, you really don't have to change a lot in this JavaScript file, but you will have to change the function name. This offer donation is this function right here, offer donation. So if your function has a different name, obviously change that. And this function takes a string, the reason, right? The donation reason. So we're going to put the reason, which is our variable that we took in from the front end, right? This reason right here, which comes in from the second input value. This value is, we have input, state. So it's three different inputs. So we have three different variables. This n belongs to n clicks. This v reason belongs to value, and this v amount belongs to the other value. So this v reason belongs to this field, which remember is the donation reason, right? So it's going to take the donation reason, a string, and it's going to put the string inside the function, use it as the string inside the function, and in the dictionary put the value amount, right? You do not, the value amount comes from here, the second variable. And that's it. And then this is an unsigned transaction. We make sure that the user signs it, and this part is where the wallet is signing it. Let's submit. Let's do my course. Submit. And here's where you confirm. This is the line 110. And once you confirm, let's go into this did it very fast actually. Console, and you'll see transaction created, transaction signed and sent right here, signed and sent. We'll wait, and then transaction mined, and we can see if we click on this, we can see what the transaction that can be mined based on this hash, right? Another neat way to see that transaction. Well, this is for the user. It doesn't really matter to you. So again, it may seem complicated, but if you have any questions, please, I'm more than willing and happy to help you on in the comments in the YouTube section under the video. But once you understand this, out of 120 lines of code, you really don't have to update a lot. You have to change the contract address, which you will know when you deploy your contract to Polygon. The contract ABI, which you will know right here, right from this tab. The checkNetwork, you don't have to change anything unless you're not using Polygon. You want to use a different network ID, then change it. But you don't have to change anything in here in the checkNetwork. And the only thing you have to change in the sendTransaction is the function name, and then what variables or arguments the function takes. So you're only changing like 3 lines of code in this whole JavaScript, and the rest of the code you can leave the same. And then the rest of the app is in Python. So I know this was a lot. If you're new to Dash, I will recommend in the comment section as well. Watch my video. You can see it on top of my head. Introduction to Dash. You will explain all about the callback and how Dash works. So it'll really help you understand how to build apps with Dash. And then you can go back to see this video again, and it will probably make even more sense. Don't forget, you can support me on Patreon or become a member on this YouTube channel. This is how this channel survives, right? Through membership support. I'll appreciate you. And always remember, we are better together, so help each other out. Always help each other out.